All right, everyone, thank you for joining today to learn about the latest in API orchestration. We launched the latest version of the Akana Platform a couple weeks ago in the cloud, and we have a lot of stuff going on, and we'd like to show you today. I'm going to do a little bit of level setting with a presentation, and then Ian is going to give you a great demo of all the cool capabilities that we have around API orchestration. So let's start with who Akana is. We are an API management company. It is our mission to move data across internet protocols to integrate people, processes, things, databases, applications. We provide the foundation for connecting all of these things and managing these connections. Today, as you know, you're managing a mesh of connectedness, to quote Gartner for a minute, and that is what we do. We really manage all of those connections and interactions with your APIs inside the organization and outside the organization in order to connect all of these things. So if you want to play along with us today or try this out later at a later time, you can do that. Just go to akana.com, click on the free sign up or get started or any one of those type of buttons on our akana.com page, and that'll take you to our SaaS platform where you'll get a tenant and you can try out everything that we're doing today. Like I said, you could play along with us today, or this is being recorded and you can try it out at a later date and look at it. We also have a YouTube channel that does some orchestrations and all sorts of videos about how to use the Akana platform. So you can go to there too at that Akana Inc. All right, so to begin with, and again, I said I'm going to be doing a little bit of level setting. A successful API strategy supports each of these roles, okay? And I've been through these roles before on several of my other webinars. So you have people ranging from API designers to security architects to operations leads to enterprise architects to product managers to integration developers, okay? In large organizations, you might have actual full organizations that satisfy each one of these roles. In small organizations, you might have one person that plays all of these roles. But when you're doing an API strategy, you need someone that pretty much acts in each of these roles. Today, we're going to focus on the needs of the integration developer, okay? Now, they have specific needs, the ability to transform quickly from SOAP to REST, to be able to rapidly connect new APIs from several different sources, and we'll talk about some cool capabilities there that we have for you that are performant. And then you really need the ability to easily redact the data that you're sending across. Okay, so these are the roles, and when you're thinking about API strategies and API platforms, they should help each one of these different roles. So the Akana platform provides end-to-end capabilities, okay? We do satisfy, we try to help each one of those roles, from the API designer, which you're going to see some today. You know, how do you design that first API? How do you design a proper API? How do you document that API? To the security, API security. How do you keep up with the latest security standards? I mean, it's difficult. They're changing, new threats, new attacks, new protocols. We do that. That is our fundamental capability, is our strength in API security. To being able to do traffic management, right? How do you control traffic to different consumer bases? How do you, protect against? How do you protect your back end against different threats? And we help you with that traffic management. To having an API portal, so where you can socialize your APIs, be it to different communities, be it internally. If you have, 100 or so APIs that you're trying to socialize and manage inside the organization, to maybe the handful of APIs that you put out to partners or to the true open APIs. So we have a developer portal that can be branded into each one of those different communities. To analytics, right? You want to be able to understand the consumption and trends that are going on with your APIs. And then we also have a core component is life cycle management, right? Being able to put control around how you build your APIs, how you consume your APIs. All right, and then going back to the thing that we're here today for is, of course, orchestration, mediation, and integration. How do you create well-structured APIs from your legacy assets? How do you take APIs and combine them so that you can give the proper response to, for example, a mobile phone to reduce the number of calls going back and forth to your server and so forth. So lots of capabilities in the Akana platform, again, end-to-end capabilities to help everyone that has a role in the API strategy. So with Akana 8.0 platform, it's really the next generation of API management. What we've provided is we took a look at the user experience and we've streamlined the user experience, tried to make it intuitive to how you can design and implement and secure and publish your APIs. What you see when you log in is a new theme. The Akana platform has several different themes that you can lay on. And when you log in, you'll see the latest theme with the new user experience. We created the graphical API designer, so we made it so that you don't have to know an API description language in order to design an API. So you don't have to know RAML, you don't have to know Swagger, you don't have to know WSDL or Waddle. We can take care of that for you. We give you a graphical way to design your APIs. You can document those APIs and really create a nice API in an intuitive way. Once you fully designed your APIs, then you can move on to orchestration and integration of the APIs. And we seamlessly move you there from the graphical designer into implementing your APIs. And you're going to be seeing that today. I started touching on this above. We have enhanced API documentation. As you're designing your API, you can start documenting your API using Markdown. Okay, so you all, if you're a developer, you've all used Markdown. It's very easy to use. You can do some very robust things, and we can do that right in line. And then we have inline. One of another great enhancements is our inline testing. So you got a Swagger style appearance when you're looking at the documentation, but it's interactive and it's full of that Markdown, so you can easily understand the API. Another enhancement that we've done, going down to the bottom center, is the global deployment. Okay, what global deployment provides you is a global presence for your APIs and your developer portal. And what we do is our global deployment complies with your regional and your country-specific data privacy and regulatory requirements. So we really focus. We have a lot of customers globally that have, for example, in the UK and Europe, data privacy regulations and requirements that we fulfill. And finally, I touched on this earlier, we have multiple description language support. So you can import Swagger, RAML, WSDL, Waddle, and we can then export any one that you want. So if you import a Swagger, you can export a RAML or vice versa. Okay, and with the designer, you don't need to. You don't even have to import one. You can just start designing your API and then export any one of those. So very robust for your API description language needs. Okay, so moving on, we have flexibility and productivity for your API designers. Now, this is the reason why I put this chart in here is because you're going to be seeing this when Ian gives you the demo. Again, I just talked about this, but it really allows you to focus on your design. So you don't have to know an API description languages. You just have to worry about, okay, what are your resources? What are your verbs? What are the parameters? And what is the schema and so forth. So we completely help you design your API in a graphical user interface. You're going to be seeing a lot of this in the demo. It's our integrated process editor. So you move right from designing your API into implementation using our process editor. And we have a bunch of what we call activities that help you configure your process, so you don't have to do a lot of coding in your process. So you can, we have splits and joins. We can use, do transformations with free marker templates. You can use XSLT if you want. We've got scripting capabilities. You can save off processes and reuse processes. You can save off scripts and reuse scripts in several different processes. So it's a very robust API orchestration, integration, and mediation capability that you're going to be seeing here in a few minutes. Finally, we get asked this a lot: what's the difference between the API gateway and the ESB? Now, remember at the beginning I said that our core function is to really to move data across internet protocols to integrate people, things, data, databases, applications. We really manage those, we help with those connections, and we manage those connections. And how we manage that is through the interaction layer, okay? This interaction layer is supported by your API and services gateway. This is where your micro-orchestrations occur, your mediations occur, your transformations occur. Now, this interaction layer really manages everything that is interacting with your APIs inside your organization, outside your organization, to your partners, and to the external developers. Now, this interaction layer interacts with your traditional ESB or your traditional integration layer. Now, this would be where you're doing your heavy message, processing, where you need to do transaction rollbacks and commits and all of that type of stuff. Those heavy, traditional ESB type of functionality, if you need to do that. The interaction layer would interact with that traditional ESB layer. It also interacts with your application layer, where you're doing your business process orchestration. You might have done some service orchestration in there, and they're all exposed as, either SOAP-based services or REST-based services or MQ-based services off of those traditional layers, or it goes down into and touches with your information management layer there. So one thing you got to think about the interaction layer, it's there to work with and manage all of your connections with your APIs. This layer needs to be fast. It needs to be able to change. You need to be able to micro-orchestration very, very rapidly in a matter of a few minutes to a few days, instead of 6 months deployment that typical ESBs and so forth do, because this is your interaction layer, okay? We provide a bunch of different services that work with the interaction layer, from our security services, as I said before, which hook into your existing single sign-on and federation capabilities, but provide all the modern security that I talked about earlier, from your authentication and authorization, be it, OAuth or OpenID Connect, JSON Web Tokens, and all of that type of thing. We provide the analytic services, as I mentioned before, management services for both APIs, meaning from a RESTful type of an API, to service management being from the traditional SOAP and MQ-based services. And then we provide all of the developer portal services as well. So this is how the Akana platform would fit around your existing infrastructure to really bring you out into the Internet of Things, to bring you out into the API economy, and help transform you into a digital enterprise, leveraging your existing capabilities and fitting into your existing architecture. With that, we're going to be transitioning to the demo. I want to say again, you can go and self-provision yourself a tenant and start to play and build and start managing your connections right now. And then I'm going to hand it over to Ian. If you have any questions, we'll queue them up and we'll answer them in the end of the webinar, and I will transition it over to Ian for the demo.
Thank you, Laura. I just lost a bet. I
told you.
I bet there was absolutely no chance whatsoever that Laura could get through 9 slides in anything less than 25 minutes. Well, I was wrong. And those are words you will not hear me say very often, so make the most of it, Laura. All right, so what I want to do is just walk you through a very simple process of using the orchestration capabilities in our platform to create a mock API, basically, or create a mock implementation for an API, to be more specific. So this is an existing tenant that we use for some demos. So I'm going to log in here as myself. And yes, this little avatar in the top corner is exactly what I look like. I am a cartoon character in real life. I'm going to just create an API, little plus button here, and add an API, and I'm going to keep it simple. I'm going to, rather than importing an existing Swagger, because while I may have one, I'd rather start from scratch, I'm going to create a nice new API that I'm going to call Demo API. I don't have an endpoint for it right now, so let me select an advanced option and choose an orchestration. So I'm creating this API as an orchestration. Once we start wading into this, I get the opportunity to design it and create an interface. I'm going to keep it incredibly simple in this case. I can just, you know what, I'm just going to delete the existing resource that I have and add a new one. My resource, I want a nice simple operation. It's going to be a get on with a parameter of ID. So just supporting the get verb. I could also add, well, you know what, I may as well go ahead and add delete and put for reading, updating, and removing the resource. In this case, I'm only going to mess around with the get resource. So let's take a quick look at what I've done there. This resource is set up. It has a single parameter called ID, which is a path parameter, and it's of type string. I haven't defined any responses. I could formally define the response as a JSON model, but I'm not going to bother with that right now. And I'm using the API default for the media type supported. Haven't set the API default yet, so let me go ahead and do that. I'm just going to make it JSON. It's just a JSON API. There's a lot of other things we can support there, and we can extend that list very easily. But out of the box, these are the capabilities you get. So I'll save my API definition, and that's a very simple thing. I'm going to come back to that a little bit later on and show you documentation and things like that and how we can deal with that. The product created a default implementation for me, and I'm going to show you what the implementations are in just a second. And it's given me links to download Swagger, RAML, Swagger 1.2, and Waddle if I want to do that. And I'll show you what the Swagger looks like as well in a second. But for now, I just want to get on with creating the basic service. So let's take a look at the implementations that we have right now. I have a live implementation, and that's it. I don't have any others. So what I'm going to do is go into my implementation, and actually I'm going to sort of show a little bit of a best practice here. I don't really have a live endpoint for this API yet, so I'm going to delete this implementation. And I'm going to start again with a new implementation. This time I want to create a sandbox. So out of the box, our platform is configured to support live and sandbox endpoints and implementations. And you can extend that list. It's a very easy thing to do. Create more and create different types of implementation. In this case, I'm just creating a simple sandbox. I could use Markdown to document what type this is, but I'm just going to say a mock implementation. Oh dear. For my demo API. And it's an orchestration pattern, not a proxy pattern. The reason I talk about this being a best practice is your live implementation is likely to be a proxy for a real endpoint. But your sandbox implementation may well be an orchestration where you're creating the mock API yourself. So I'm going to show you how we can very easily do that. So I'll save the implementation, and that creates a basic implementation with a whole bunch of useful, sensible defaults. So for example, it created a single auto-generated host name for the API hosted. I mean, I'm working in a smoke test environment here, so default API host name, and I can go ahead and edit this. I can change it to provide a vanity URL for it if I want to do that. I can add or remove the HTTPS endpoints. By default, it has both, but I'm not going to do that. What I do want to do, though, is add a policy. I want to make sure that I'm collecting auditing data for this thing. It's a demo API after all, so I'm probably going to mess up the code at some point. So I'm just going to attach an auditing policy that collects all the information about the thing. I can go ahead and add additional security, OAuth, various other things, but I don't need to do that right now. So I'll save that. And that's basically created the implementation, but right now there's really nothing behind it. So I'm going to work on this get operation. And I'm going to go in here and edit the process for the get operation. Nice, simple thing. At the moment, all it's doing, it has a receive and a reply, which really isn't going to do anything for me whatsoever. So what I'm going to do is put some things in the middle of this. Specifically, I'm going to normalize the incoming request. I'll explain what that does in just a second. And I'm going to add a template, which allows me to generate response content. So actually, you know what? Let me change that process just a little bit. I'm going to remove the normalization for now. We're going to build this thing up bit by bit. So I'm going to use FreeMarker, which is a templating language, to generate some static content. So we will generate static content in the form content type of application JSON, and we'll put it into the default message content that flows through the system. So if I look at my reply activity here, it's replying using the message variable, and that's the message variable that I just populated in this FreeMarker template. So I'm going to save that process and go back to my API. I'm going to look into the documentation here because I have a test client built into the documentation. And I will look at the method here. I've got an ID parameter. We'll call that ID Ian. That's me. I don't need to specify any other parameters, and I'll send a request, invoke the request, and I get a response back. Hello world. That was the static content I plugged into my API. Now, overall, that's really not all that useful. But it gives you the basic concept for what we're doing here. What I'm going to do, though, is I'm just going to grab this URL and paste it into another browser window here and put my name on the end of it. Just demonstrate that I can get a response, because that will make it just a little bit quicker when we're going through the testing process. Rather than going back into the documentation every time, I can just test directly from here. So what I'm going to do now, though, is I'm going to go back and show how you can do interesting things with parameters. And that's where we get back into the normalization. So what normalization does is it takes the incoming message and it constructs what's called a normalized message in a JBI, Java Business Integration context. Our platform's built on a JBI backbone. So by normalizing, what we do is we take that incoming request and we process it. We look at the binding and we say, okay, well, do I have any defined parameters? What content do I have? And I create a normalized message that then gives me the ability further down in the process to access all the pieces that were defined on the message. So at this point, my message has one defined parameter, which is called ID, and I can access that within my FreeMarker template. So instead of saying hello world, what I actually want to do is respond to the original requester. So I'm going to add in a piece of FreeMarker templating language. That's what the FreeMarker template construct looks like. And from my message variable, message, I'm going to invoke the function getPart, and I'm going to retrieve the ID part of the message. So that has replaced the content in this piece of the JSON document with an extracted part of a FreeMarker template, and I'm getting one of the message parts that I parameterized as ID, and I'm returning that in my content. So I will save this process, and when I go back and send another test request, we should be able to see that it'll respond with hello Ian. And if I change this to Laura, we get hello Laura. Okay, all well and good. So we've now started to use a parameter in a response. We're accessing things that I defined on the message, and we're able to start to do some interesting things. Now, there's a couple of other things that I'm going to show you here. Specifically, I'm going to talk about how we access other parameter types and how we define them. And I'm also going to show some split join capabilities. So let's start with the split join, because that's sort of kind of interesting. I'm going to keep the example incredibly simplistic. So actually, let's start. We'll just give myself a little more room in the process here. First thing I'm going to do is split my process into multiple threads. So we'll split the process here, and we will have one of the threads run off and invoke the normalize. And then I'm going to use a script activity in the second part of this split out activity. Before even running this free marker template, I want to rejoin the process, put it back together. So let me reconnect that here. You can see it's all quite straightforward. So I've just rewired this thing. I've split this into two things. One half is going to normalize the request, nice and simple. The other half is just going to run a basic script. Now, let's pick some kind of lame example of what we can do in a script and just say, you know, I feel like I need a random number that I can access somewhere in the script. So in cooking show mode, here's some code I wrote earlier. Nice and simple. I just don't feel like retyping it. So basically, I am using the JavaScript math library to generate a random number between 0 and 100 in this case. And I'm writing it out as an audit log record if I were in debug mode. And then I'm just setting a variable in my process context that I can use. So I'm creating a variable called random with the results of the JavaScript math function. Very simple thing and kind of meaningless, but what it really just shows is that I can run parallel process. So a more normal thing to do would be to invoke multiple different microservices in parallel by splitting your process up and then aggregate the results of those microservices. But just for the sake of simplicity, I'm rejoining the process and showing you what sort of things we can do in parallel here. So now coming back to my free marker template, I can say, actually, you know what? I'm now going to add a second piece of exciting data to my response, and I'm going to say your number is, and once again, we go ahead and access our free marker templating language, and now it's nice and simple. I quite simply have a string variable that I added to the process called random. So I can access that directly through the free marker templating language, and now when I save the process, save all my changes, I should get a nice simple addition to my response. It can take a few seconds for the process change to refresh, but there it is. So each time I refresh this, I should get a new random number. So I've extended my response, generated things out of multiple threads. Nice and straightforward, nice and easy. So coming back now, let's look at the next step in the process where I decide, okay, you know, I've realized that what I actually need to do is extend my service definition and add some additional parameters. Or in this case, I'm just going to add one additional parameter. So I can edit my service definition. Look at the service definition here in the system. I'm working on the get operation. I want to add a parameter. I'm going to add a parameter called type, and let's document it. Type parameter, and I'm using using Markdown, so this is going to be a heading. Type parameter, the type of the resource. So I'm making it a query string. I'm not going to make it required. I'm not going to provide a default value. and I will allow an empty value. It's data type string. I don't need max or min lengths, and I don't need to provide a specific format for the string. So I've added a new parameter, and I've documented it, and that is really all I need to do at this point. Now, that doesn't necessarily change anything until I come back to my implementations and I say, well, I want to access that, that parameter in my request. So I'm going to edit the process. Don't need to change anything except in my template, where, because I've already normalized the request, so the normalize activity is going to already have taken effect. So I can come back in here and I can say, okay, well, let's add another piece here. I will decide that I want another parameter in my JSON document called type. And this time I am going to, again, basic free marker template construct. But this time it's a bit more interesting because I'm going to use my message get part model again. I'm accessing the part of type. But this is a bit more interesting because query parameters can be multi-valued. So as a multi-valued attribute, it's going to get returned as an array. But I don't want to access an array here. I want to access the value of the array, specifically in this case the first value of the array. So I'm just going to assume that there's one value and one value only in the array. Sounds like a line from Hunt for Red October. One ping only, Vasily. So I'm going to access the first value from my array and return that as the type parameter in my free marker template. And I'm going to show you in a second a few things you really should extend that with to add some error handling and those kind of things. But for now, let's go ahead and run that and see how this works. There we go. I get an internal server error. I'm going to come back and show you why I got the internal server error. But for now, let's add the query parameter. Type equals, let's say, evangelist. And I get the type parameter added. So this worked, but why did it fail the first time? Okay, let's go back and check that out. I'm going to come and look here at the monitoring data for this API. We can see some traffic, tiny little traffic's been flowing through. Let's look at the logs. We get these favicon fails coming in because I don't have a favicon defined, but that's not really relevant. That's just the browser looking for the favicon hit. Let's look at this request that failed here. And I can look at the request. There's nothing in it. As we can see the headers. I can look at the response. And again, here's the response. But in the info tab, I'm going to see the error. Now, FreeMark is quite nice because it gives me quite a lot of information. So what this tells me here is that something evaluated to null or missing, and message get part type evaluated to null or missing. Well, of course it did, because when I sent the request without a type parameter, I get an internal system error. That's the error I generated. And the system error is, it's not well handled because I haven't put anything into my process to handle that for me. But I at least see the information in the logs. Okay, so what am I going to do about that? Well, again, FreeMarket gives us some quite nice ways of dealing with those things. So let's take a quick look at what we can do there. Come back into my process. And in the FreeMarket template, I'm going to specify a default value. So, gets slightly complicated, but basically what I need to do is wrap some parens around this thing. So I am going to put parens around this. So that's the template I'm trying to extract. And if that's not found, I can use the FreeMarket default to specify an alternate string. Now, I can't really just specify a string because it has to be encapsulated within an array. So I'm creating an array called with one value unspecified, close the array, close the parens I added. Then just to be safe, I'm going to wrap all of this around another set of parens so that we know that the result I'm getting out of this is an array, and I'm going to access the first element of the array with this little extension at the end here. So what I'm doing here, I have the template extraction, if there's no value for that, which should be an array if there's a value, if there's no value, that's what the exclamation mark says. Oopsie. If there's no value, then I'm going to return an array of my own creation that only contains one value. And then I'm going to take the first element of that array. So let's give that a go. We'll save the process. And coming back to my request here, let's go with Ian query type equals nerd. And I get a response as expected. Now, if I take out the type parameter, I now get unspecified because I put that little bit of error handling into the free marker template. Nice, simple thing. Okay, so one more thing I want to show you while we're in this process is just some basics on how we would go about documenting the API. I hope this makes sense, by the way. Very simple process. The split's probably unnecessary, but it just helps show that we can handle things in parallel. And as I say, a more typical example would be to use multiple invokes in this process. In fact, while I'm in here, let me just show you what an invoke looks like. An invoke is kind of an interesting beast because what I'm going to do with the invoke is I could search for services. Let's say I'm looking for my order service here. I can search for services that do something around ordering, and I find a few different versions of it. I've got an order manager service. I've got a SOAP version. I've got a front end, all sorts of different things going on. I'm going to use the SOAP service as a back end, pick the interface, and pick a specific operation. So I want to get all open orders, for example. And when I then wire this activity into my process, what happens is the process is working with normalized messages. That's basically an abstract construct, and it realizes that it needs to invoke a SOAP service. So the gateway goes ahead and generates what's required to invoke the SOAP message. So it'll generate the body from whatever content it has. Let's say the content's in JSON form. It's going to mediate that dynamically to XML. Now, in many cases, the resulting XML document won't match what the SOAP service expects, so you may need to have done some transformation before you get to that step. But that's another issue. What's particularly interesting, though, is that you're entirely abstracted from policy. Perhaps the SOAP service has a requirement to use WS security with a signed message element and encrypting certain pieces and using a SAML assertion to authenticate the end user. What's going to happen is that the process is going to use all the information it has in its security context. So user information that was extracted from the HTTP session, maybe using OAuth on the inbound request, will be stored in the process context as a security principle, and then will be used in the outbound request in the invoke activity to properly specify the headers in the defined SOAP service. So it's an incredibly powerful construct that allows you to invoke services of all different kinds without ever having to worry about what kind it is. So that abstraction is a really powerful thing. Anyway, I'm not going to go through that process right now. Just remove that. What I want to do, though, is show you a little bit of information on how you would go about documenting the API. So editing the operation again, I showed you the basic process of documenting the parameter. So I created a description for my type parameter. But let's go ahead and add some basic documentation to the API. So first things first, we probably want to create a description for the top level of this operation. So we'll call it the get resource operation. And it does something simple. It gets a resource, supports query params to identify some specific aspects of the, oh dear, typing's not too good today, aspects of the resource. Okay, And I decide I want a summary that's going to give me something a bit clearer to identify the resource type. So we'll call it get resource. And then when I save that, we start to see a little bit more information appearing. We've got some data starting to show up in our documentation type. I can go ahead and if I want to, I can say, actually let's come back to this and say in my description here, a resource typically looks like, and I can use triple backtick notation to add some code. We'll call it key value, and I'm not really going to document any more of it. Obviously, you typically paste an example JSON document in there, or whatever code you choose. So that then starts showing up in my description information. I can go ahead and define the response in terms of specific models, but I haven't created a model. I can add JSON schema-based models as defined by the Swagger spec and easily assign them to responses or requests if I'm using posts or puts, and start to define and document my API reasonably thoroughly in that manner. For now, I'm just going to save this basic amount of documentation. But the beauty of all of this is that when I now go to the Documents tab here and I look at the documentation for the API, I see that my summary has been added to this list. And in the list, I start seeing the documentation appearing. I can view the description of my type parameter. And anything that I add in the markdown is going to appear in real time in the resource. So in the operation documentation. So we're able to very quickly and easily extend the documentation for the platform. And at the same time, I can go ahead and open up a file manager and add additional files, upload any kind of documentation I want, and make it all appear in a table of contents inside the documentation navigation. But I'm not going to take the time for that. That'll be subject of another webinar at some point in the future. Anyway, with that, I think we're done demoing. We've shown the basic functions of the platform and the way it works. We've shown how you can create a mock service very quickly and easily in the process of creating an API. And there's actually an immense amount of code that you can run inside those orchestrations. You can get really quite sophisticated if you want to do that. But with that, let's see if we have any questions to take. So let me bounce out of my sharing here.
Look in the chat box.
Yeah, I'm checking. Question we had on import-export of Swagger OpenAPI. Yes, we do. You know what? I should actually come back and reshare my application. Slightly irritating in WebEx in that I can't see questions at the same time as demoing. So Laura, maybe you can check out any questions and see if there are any other questions that we have in there. So yes,
hold on a second.
Go ahead.
When you share, I can't see the questions either. So
you can't.
Hugh, can you see the questions?
Yes.
Okay. Well, then Hugh will do it. Read the question.
Okay,
hold on one second. Hugh, hang on a second. I had a question that I'm going to answer right now on whether we support import of Swagger / OpenAPI. The answer is yes. So first of all, you saw me create an API definition just manually using our graphical editor. So I can extract the Swagger document just by clicking on that link, and there's the Swagger for the API that I defined. I can also, when creating a new API, say that I want to create it using Swagger, RAML, or WSDL, either via URL or by file. So I could very quickly and easily define APIs from any of the core descriptors, and then having imported a descriptor or manually or graphically defined the API, I can extract any of the other common descriptors from the platform. So it gives full-blown descriptor language mediation. It's really a pretty sophisticated capability.
Very good. Okay, so the next question is there any difference between API versus microservices architecture?
It's a good question. I think microservices, APIs, SOAP services are all variants on a service-oriented architecture concept. Now, some API purists will immediately start screaming and rolling over in their graves at the idea that an API and a service are the same thing, but they really are. Just variants of service types. What you typically see in a microservices architecture is that the microservices are small pieces of business functionality that are orchestrated together to create an application, and the application itself is often implemented in the form of an API. So often you'll see multiple microservice calls being made in the provisioning of an API. I actually have a blog post on blog.akana.com. Let's see, it's one of mine, so we'll search for my posts. This post, Eat Your Microservices Elephant One Bite at a Time, which kind of gets into that concept a little bit, talks about a way that you can use the split join capabilities in our platform to invoke multiple different microservices in parallel in order to execute a single API request and generate a response to that API request. So I'd give that a quick read, and I link to a sample application that's published out in GitHub that you can use to sort of test this process out and see the way that it works. Kind of an interesting little question there. Anything else, Hugh?
Yes. So there's another question: is the integration layer that we saw in the architecture diagram the same as what we call the implementation layer in the demo?
Laura, you want to take that question?
Yeah, no, it's not. Is there a way I can bring back up the presentation? Can you stop sharing?
Yeah, I can stop sharing, and I can make you the presenter.
All right, so now you should see the presentation back up with how Akana fits into your existing.
There you go. Now you're the presenter. Got it.
Okay, now you see us. So this is the interaction layer. The stuff that Ian was showing falls into this micro-orchestration, mediation, and transformation category, and that implementation layer inside the demo that Ian was showing fits in here. It's part of the integration capabilities at that interaction layer. The traditional integration layer, that is your, if you have an existing ESB where you're doing heavy message processing and transformations and two-phase commits and all of that kind of stuff, that's happening down here. Stuff Ian is showing was up here in the interaction layer, because you remember it was very, very quick. The stuff that we were doing very, very quick, very rapid, very small type of micro orchestrations and transformations. Any other questions?
Hugh, I can actually see the questions now. So let me take the questions. So yeah, we covered import export to Swagger. We do not currently support protocol buffers or flat buffer response formats. Well, actually, as response formats, we do. We don't handle any mediation for them. So we handle the response types, but we don't have any mechanism for converting them into anything else. So we can stream them. A question on the open source projects we incorporate. There are actually quite a few, but FreeMarker and Markdown are a couple of specifics. We have not yet published the graphical editor that we created as an open source project. It's kind of deeply embedded inside the UI, but it's certainly something we're considering, and we're interested in ideas. So that's certainly publishing our graphical editor as a way of generating Swagger annotated with Markdown is one of the projects that we're definitely considering, and we'll continue to look at that. The last question we had here is, we created an API using the GUI and exported Swagger. So the question is, can we now take the Swagger, modify it offline, and import to update the API? Absolutely. What you do is we have pretty sophisticated versioning capabilities built into the product. So you would simply create a new version of the API and define that version using the Swagger by importing the Swagger that you had edited offline. And you can edit that Swagger using either manually in an editor, which I think is the easiest way to do it. I'm a Sublime Edit fan myself. Or you can use the tools that the Swagger Open API project provides for graphically managing and editing your Swagger documents. I don't think we have any other questions that are out there right now. So with that, I think we'll probably call it a day. Wanted to thank you all for dialing in and checking out the webinar. And we are going to publish this on our website, so you can always come back and download it and review it again at your leisure. So once again, thank you to everyone, and we will call that a wrap.
Thank you.
The leader has disconnected. The conference will be terminated in 5 minutes.